Sir, can you please check once? Yeah. Yes, sir. Your screen is sharing now.
Very good morning to all. So you can hear me, right?
You're audible, sir.
So the FDP started, I think, yesterday, madam.
Yes, sir.
So this is for outsiders or your college?
Outsiders also there, sir. Apart from KLU faculty and students.
Okay. So
And last week we have organized one more FDP. This is a continuation FDP, sir. Last week we have organized on recent trends in embedded systems and IoT applications, sir. So to the continuation, this week we have planned on advances in machine learning, sir.
okay.
This is the second day on machine learning, sir.
So what are the topics covered yesterday, madam?
Yesterday, resource persons was discussed about what the core concepts of machine learning and KNN algorithms, etc., sir, and its applications, how to pre-process the data, etc., sir. Last week's sessions, it's purely on embedded system design about zinc boards and IoT application aspects in various different domains. That was engaged, sir.
So I think it is second day only. I think nobody introduced neural network sector. Okay.
Yes,
so
sir.
if you are comfortable, then I'll be talking on CNN, convolution neural networks. Okay. Or otherwise, we can do one thing. If we can discuss on other machine learning algorithms like multiple regression and application to image processing, and k-means clustering algorithm for image color quantization, so on. Or I can, the same thing which I gave is convolution neural network for desert recognition is what I gave. So these three topics, if anyone, if you want, I am comfortable. So that is up to you whether I can go ahead with the same topic, right? Convolution neural network for image processing application. Should I go ahead, or you want basic machine learning algorithms so that somebody would be covering CNN?
Basics was discussed a little yesterday, sir. So I think you can continue with the CNN itself, sir.
Achha. So I think all of you are comfortable with this. Okay. And anyhow, the topic is advanced machine learning. So it can be discussed today, and then autoencoders and GANs and all can be discussed in later classes. Okay, yeah. So now let us go ahead. So can I make the class interactive, or it should be one way? Can I ask questions indirectly? The question is that
Yes,
can
sir.
I ask you questions or not? Questions are
Definitely, sir.
allowed?
You can. Yes, sir. Yes, sir. It's allowed, sir.
Okay, all right. So now let us begin. So now let us go ahead. Convolution neural network. So neural network, I think you would have learned by this time. So this is a simple perceptron model. So where you have, uh, I think you know the neural structure, how the information is gathered by your, dendrites, and then how it is, getting processed at cell, and then how neuron fires and all. Based on, we have mathematical model, which is, the output of this Z is equal to function of, xi into wi plus some uh, bias, right? So this is what artificial neural network. Can any one of you tell me this input represents what in biological neural network? And weight equivalent representation is what in uh, biological neuron, and this activation function is what in biological neuron, and this bias is equivalent of what in uh, simple biological neuron. Anyone? If you know ANN, then I can go straight away, but just checking how much knowledge you have on basic neural networks. You know neural networks, right? So we have around 10 power 11 neurons, right? Okay, we have 10 power 11 neurons. And do you know the working of neuron, means biological neuron?
Like it sends the signals from one node to another node.
Okay. Here you have, this is what biological neuron, right? So one neuron is connected to other neuron, right? So what are these parts are called through which one neuron is connected to other neuron? If you ask me, you said, questions are allowed. That's why I'm asking. Make it class, very interactive, very comfortable. You should feel very comfortable, right? Yeah, this is called cell body. So all the signals received from dendrites. Okay, so these are called dendrites. Okay, so the information received by these dendrites is getting multiplied with synapse, means it is getting modified by the synapse. So here synapse, when when one neuron and another neuron where the node is getting connected, the information is stored there. It is called synapse, right? So the signal, it is received by dendrites and slightly modified by synapse, and the cell body receives all the signals, and the neuron get fires. When you see a person, so all of a sudden, you can recognize, after some time, yes, you are so and so Ramu or so and so the information, the neuron is getting fired, is what we say. So the firing of neuron is what we can call it as it is a nonlinear action, which can be represented by using activation function. Okay, and axon is one where this it carries the information, and sometimes the neuron fires or not fires, and sometimes it will be firing or it will not be firing. So the chemical reaction which takes place, okay, the chemical reaction which takes place uh, in neuron, sometimes it can be the temperature. Sometimes when chemical reaction happens, it uh, releases heat. Sometimes it absorbs heat. Similar kind of thing. Sometimes it may fire or it may not fire. So we'll be needing certain bias. Okay, so this is what the artificial neural networks. So the dendrites are collecting information, and then uh, the one neuron, when it is connected to another neuron, right? When one neuron is connected to another neuron, it is connected through Okay, it is connected through the axon port, it is connected through synapse. So the information which is getting received by dendrites is getting multiplied. So inputs, dendrites are representation of your inputs in artificial neural network, and synapse is represented with weights, and the neuron cell body, is firing of that. It is given by activation function. Okay, so it can be written like this. So x1 w1 plus x2 w2 plus x3 w3. But sometimes we need to add bias. So bias is getting added up. So this is what a biological neuron and then artificial neuron equivalent. So the firing of this one, generally, non-linear. So the non-linear function which I would take is a sigmoid activation function, which is 1 by 1 plus e bar minus x. Right? So this is what a simple neuron structure. So when we have neurons, neuron and neuron structures, when they are connected in layers, when you have like this, you have input layer, you have hidden layer, you have another hidden layer, and so on, and you have an output layer. So when signal is given as input, it is getting multiplied with weight, and it is added up at cell body, and then the neuron fires, which is a non-linear action, which is a some sigmoid function, is what we are trying to take. And these neural networks will be using the cases where we need where we need to approximate non-linearities. All the real-time problems are non-linear in nature. So neural networks are best non-linear approximators. So we will be using neural networks to represent non-linearity. So wherever we know we need to solve non-linear problems, then generally we'll be using neural networks. And this neural networks is proposed in 1970s and so on, and it is very popular. And somewhere around 2000 2010, the neural networks are about to die. Okay, so the area got saturated, but all of a sudden, these days we are talking about deep neural networks, right? So can any one of you can tell me, like, what is the advantage of deep neural networks? Why we are talking about deep neural networks these days? What is the problem with the basic artificial neural network? Anyone? Pawan Kumar sir? Andy Pawan Kumar. Dr. Basant Shah? Let us make the class interaction, so that you will be getting benefit and then I'll be getting benefit out of you.
Sir, hello, sir.
Yes, sir. Yeah. Good morning, sir.
Good morning. This is Dr. Basant, sir.
So where are you from, sir?
Sir, I'm from Jharkhand, but I am working here, Kale University.
Care University. Okay, sir. Nice to
Yes,
meet
sir.
you. Yeah. So I think you need to start your machine learning subjects from this year onwards, I guess.
Okay, sir.
You would have started machine learning in EC department.
CSC department, sir. CSC.
But here in
Computer
SR
science.
University, here in SR University, they started, like, universities can start machine learning program BTech in EC. Yeah, but whereas affiliated colleges cannot start. Okay, sir. Yeah. So you worked on any time neural networks, sir? Used any time neural networks? Or any problems you would have used neural networks? You used or not? Sir, am I audible? Vasant sir.
Yes, sir. Yes, sir.
Yeah. So now all of a sudden, these days, people are talking about, we have neural networks from 1970s, right? So now deep neural networks means, here you have, first hidden layer, second hidden layer, and so on, right? But these days we are talking about deep means you have n number of hidden layers, around 100 to 200, which is very, very computationally complex. So, but these days, deep neural networks are gaining popularity. Reason is, anyone? What would be the reason? Dr. Karthikeyan? Sir, it is just interaction, to hold your concentration only, I'm asking question. Dr. Karthikeyan? Dr. Jyoti? Any idea? Like, why people are talking about, advanced machine learning means, you have to see, these advanced machine learning algorithms and deep neural networks only.
Sir, deep learning is a subset of machine learning, sir.
Correct? Yeah, deep learning is a subset of machine learning.
Machine learning, in you have a deeply study smart, sir. According to me, sir.
No, even deep learning also, it is neural networks only there.
Yes, sir, yes.
Yeah, but almost deep neural networks are about to die. But these days we are talking about deep neural networks. Any advantage is what I'm asking before starting up my class. Yeah, let me. Another. Ever live offline, ever live. Yeah. So now let me. So these deep neural networks can be used for computer vision problems, for image processing. So like digit recognition. This zero, somebody writes, here if you try to see two, somebody will write two like this, another fellow will write two like this, but we have to recognize it as two. Okay, even 9 2, so many cases. This is 7, digit recognition problem. So generally, this is digit recognition. The database which we use is MNIST dataset. MNIST dataset. MNIST, MNIST dataset, in which your digit is represented as 28 cross 28. So 28 cross 28. Your image is represented using 28 cross 28. What do you mean by that? Image is 28 cross 28. What do you mean by that? This is an image of digit 7. So it is 28 cross 28. What do you mean by that?
That means, sir, whenever you present 7 using image, so it is pixel value 28 by 28. That means pixel 28 into 28.
28 by 28 pixel value. So this
Yes.
digit has to be recognized by neural network is what our problem, right? So then in neural networks, we have input layers, we have hidden layers, and we have output layer, right? So the structure of neural networks is like this. The structure of in layer, you have input layer, you have hidden layer, and you have output layer. So output is what? Digit recognition. How digits are how many? 0 to 10. So 0 to 9. 0 to 9 means you have 10 digits. So in output layer you have 10 neurons. Clear, sir? All of you? In output layer you have 10 neurons. And hidden layer you have any number of neurons, that is your wish. And in input layer, if a digit it is, if it is a digit of 7, right, then 28 cross 28 means all these pixel values is what we need to give input to your input node or input neurons. So 28 cross 28 is 784. Is it fine? Is this understood now? Input layer, you have 784 neurons. Why 784 neurons? Is that understood?
Yes, sir. Yes, yes.
Yeah. So now let me take, I have a neural network, which I have two input neurons in the input layer. I have two hidden neurons in the hidden layer, two neurons in the hidden layer. So how many weights are associated with the input neuron and hidden neuron? You got my question? If you have two input neurons in the input layer and two hidden neurons in the hidden layer, how many weights are associated with input and hidden layer? So here you have W1, here you have W2, here you have W3, and here you have W4. So total how many weights? Total how many weights? So you are not interacting means you are just connected, but you don't want to participate. Deepa madam, you agreed no in the beginning? Whether they are there or not in the class, just for participation certificate like that, they are logged in or what? Dr. S. Koteshwar Rao.
Sir, internally, I think calculated x1 into w1 plus x1 into w2, sir, like that, sir, I think.
Now, how many weights are there, sir, between input and hidden layer?
So
Here two.
after addition, only get one, I think. After addition, all things.
That is okay. No, I'm talking about only weights, sir. You have input layers and you
Yeah.
have hidden layer. So you have two neurons in the input layer, two neurons in the hidden layer. So total, how many possible weights are?
4.
4. That's what the question I asked.
Yeah, okay,
Okay.
sir, absolutely. Yes, yes, absolutely, sir.
Now you have 784 input neurons here in the picture. And here you have 15 neurons in the hidden layer. How many weights you need to update using gradient descent algorithm or some algorithm in neural networks? So we have, before learning CNN, we have to see what is the failure of neural network, right? So you have 784 into 15, no? 784 into 15 weights need to be updated, right? Weights are associated with input neuron and hidden neuron, right? Is this understood, all of you? Yes or no? 2 into 2, 2 means 2 into 2. The input neurons in input layer are 784 and 15 neurons in the hidden layer. Then 784 into 15 weights are associated with this structure, and this 784 has to be updated. Is that point taken? Umamageshwari. Umamageshwari. Madam, if you are silent, I cannot go ahead. That is my problem. So this is what one simple neural network, which you have 784 input neurons, 512 neurons in the hidden layer, first hidden layer, 256 neurons in the second hidden layer, and 128 neurons in the third hidden layer. Okay. And then output layer, you have 10 neurons because digits are 10. So 3 hidden layers are there. If more number of hidden layers, then we call it as deep neural network. Okay. So what we need to do is we can use this for image classification. Now, so we talked about grayscale image. Now we are talking about a color image. So color image, every pixel is assigned an RGB value, 255, 255, 255. 0 to 255 is what maximum pixel intensity. So now in neural networks, what we do is we extract features and then we give as input of neurons. So cat means it has 2 ears on the head is what we say. Then if that is the input, if it is given, then it should say like the second picture also it will classify like it is a cat, and the third picture also it is a cat. That is the problem with neural networks. Then similarly, digit recognition also. Somebody will write 9 like this. Okay, so then the features, when you train neural networks, train neural networks, then where you have pixels, the pixels has different values, then you should train like this. And sometimes somebody will write if the digit is present like this in the image, but your training was happened like this. So the pixels are in the middle. Right now there is a shift in position in the 9, then it will not classify like it is 9. That is a problem. And this is one more variation, like somebody will write 9 like this, not like this. Then that is a problem. It will not recognize as 9. And somebody will write like this. Then that is and then it will not be 9. So to handle variety in digits, we can use simple artificial neural network that we'll be using. But the problem is this. Input you have, let us take 7 by 7. The image is represented by 7 by 7. 49 neurons in the input layer and 49 neurons in the hidden layer. The total weights associated with input and hidden are 49 into 49, 2401. And in the next layer also 49 into 10, 490 neurons need to be updated. So you will be using gradient descent algorithm to update the weights. Okay, to update the weights. Right. So updation of weights is computationally complex. It makes the network computationally complex. So for grayscale image it is all right, but when it is color image, the problem is this. In MNIST dataset you have 28 into 28 pixels. Now if I use 100 neurons in the first hidden layer, then you have 78,000 parameters. Okay, 78,000 parameters. And your image, if it is 256 cross 256, then 56,000 pixel means 56,000 neurons in the input layer. And if you use 100 neurons in the hidden layer, 56,000 into 100, which is 560k parameters of weights you need to update. That is what computationally complex. Now, if you try to take an image which can be of 1920 cross 1080 cross 3, how many neurons I will be requiring in the input layer? I want to recognize which animal in the picture. The image size is 1920 cross 1080 cross 1003. How many neurons I'll be requiring? Dr. G. Madhavi madam. Whether they are there in the class or not? Basant sir? Basant sir? What is happening? So am I audible?
Sir, you are audible, sir.
Yeah, fine. So Rashikar sir, nobody is responding. What would be the reason? Questions are allowed, not allowed.
Maybe some internet problem with them, sir. You can continue with it. The recorded thing I will send to them, sir.
Okay. All right. No, if it is one-way lecture, these lectures are also available in class, YouTube, right? Yeah. So the image is 1920 cross 1080 cross 3. Means the neurons which you require are 6 million. Okay, 6 million neurons are what required in the input layer. Now, in hidden layer, let us take there are 4 million neurons. Then total number of weights associated with first neural input layer and hidden layer are how many? Tell me. Kullur Venkatratnam, sir. Ah. Venkatratnam, sir. Okay. So if it is 4 million, so 6 million into 4 million, around 24 million neurons need to be updated. So the neurons between input layer and hidden layer are 24 million. So 24 million neurons need to be updated using gradient descent algorithm. Means it is computationally it is very high. So those many computations are not possible in earlier days, but these days, the computations are possible. Reasons are anyone embedded systems. You said you have undergone embedded systems FDP earlier, and these days what is the thing? Why neural networks or deep neural networks we are talking about these days? They are computationally highly complex. Where you are running your programs now? In your computer or in cloud? What for me? Okay, so there are 24 million neurons need to be updated. So it is very computationally, so too much computations with ANN. And sensitive to location of an object in an image. When we train a neural network and then if there is a shift in position in the desert, then there is a problem. It will not recognize. That is a problem. But these problems can be resolved with CNN, convolution neural network, and what are the advantages of convolution neural network we'll be seeing now. So now let us take, this is an image. So this image, this animal is called koala. So whether it is koala or not means what we say, we try to see its ears, its eyes, its nose. Okay, right. So once these things are there in the image, then we try to compare with this head looks like a dog or cat or koala, some other animal. So by seeing the ears, we cannot say like it is a dog or a cat. So our neurons, somewhere we would have seen a books like it is a koala kind of thing. So our neurons got trained using these features. So first we try to see eye, nose, ears, and all. The head is present or not. And once head is there, then its hands are there, how hands look like, and how legs look like, and then whether it is body of the koala or not. So head and body both are present means whether it is koala or not. And similarly, when we try to go on with the digit recognition, right, there is a loopy pattern on the top, there is a diagonal vertical line in the middle, and there is a diagonal line in the bottom. So if these three are there, then we say like it is 9. Right. So then we say it as a 9. So loopy pattern. Then what we'll be doing is we will be performing, a convolution with filters. So you have a loopy pattern. You have a feature. So you have a loopy pattern filter and vertical line filter and then diagonal line filter. So you have three filters, and whether these three are there or not is you can find it out using convolution. Okay, this you can try to find it out using convolution. So then we will be using convolution neural network. A convolution neural network look like this. The first is convolution operation, then subsampling. Okay, then convolution subsampling. So this subsampling, first we try to see convolution, and then we try to see subsampling section. So then you have convolution subsampling, like that you have 100 to 200 layers are present. And computationally also it is less if computations it requires, how that is we try to see with the help of convolution. Then you have fully connected neural network like as we discussed earlier. Okay. So now coming to, let us try to see convolution. How do you perform convolution? If the filter element is 1 into -1, then when you try to perform convolution on 1D, so 1 into 1 plus 1 into -1. That is first convolution. Then what you do, then you shift, right? Then you try to perform convolution of this element with filter element. So 1 into 1 plus 1 into -1. Then you shift here. Like this, you to perform your convolution. The result is this. And coming to the convolution, here you have 6 by 6 pixel, and the filter is of 3 cross 3. When you try to perform the convolution, what happens? So then this filter is what you try to do convolution like this first. So what you do, 3 into 1 plus 0 into 0 plus 1 into -1 plus 1 into 1 plus 5 into 0 plus -1 into 8 plus 2 into 1 plus 7 into 0 plus 2 into -1 is what you try to perform. So the resultant is 4 cross 4. How that is now you can see. But if you try to see the convolution, okay, so then result is -5. So this -5 is entered here. So is this understood now? The convolution is understood now. So then next what we do is we shift, and then again we try to perform convolution. and then the result is what we enter here. Okay, so then we'll be performing convolution, and then we will be entering, and like that, we will be scanning. So if it is a filter of loopy pattern filter, and if it is there means this is what the complete convolution of this input image with the filter. So the generalization rule is, if you have n cross n input image and filter size, if it is f cross f, then output is n minus f plus 1. N minus f plus 1. So here n is 6, f is 3. So n plus f minus 1, which is 6 plus 3 minus, sorry, it is n minus f plus 1, yeah. N minus f plus 1. Is 4. So it is 4 cross 4 is what. So is this understood now? Is this understood?
Sir, you can continue, sir. Nobody are responding.
sir. Yes, sir.
Nobody are responding, sir. I will continue. You can continue, sir.
Yes, sir. Please pardon, please, sir. Again, sir, please. Hello.
So is this understood, sir? Now the
Yes, sir.
convolution.
Yes, sir.
Yeah. Now, sir, so this is what the generalized formula. We will be, again, see, in my last thing I have said, like, the 6 million into 4 million, 24 million weights need to be updated when you use neural networks. But when you use convolution neural networks, we can reduce the computation, is what the proposal. Now let us try to verify that. So now let us take, this is what a digit available, and this is what loopy pattern filter. And when you try to perform convolution of this over entire image, then the resultant image, when you get like this, okay, then irrespective of position of where the loopy pattern available, the convolution will identify with. That is what the advantage. So here, when we try to perform our image with a filter, we are extracting features. So the convolution operation extracts the feature of this. But whereas in neural network, we need to extract feature and then we have to give it. Like in audio application or speech recognition problems, we need to extract features like Mel spectrum and pitch value, okay, and so on, is what we extract it and we will give it. But whereas in convolution neural network, the first layer is responsible for feature extraction, which is called feature map. So you have 9, and when you perform convolution with loopy pattern, you can find 1. And if you have 6, then loopy pattern is means the loopy pattern is there in the down. But the moment it is 8, you have loopy pattern on the top and bottom. Okay, and when you have 9 and 6, you have position. So it will, irrespective of position variations, the convolution operation will perform or extract the features. Yes, loopy pattern is there or not. And similarly, we have vertical line filter, and when you perform a convolution, then vertical line is there in the middle, and then you have diagonal line filter. Okay, and when you perform convolution, yes, loopy pattern is there, vertical line is there, and diagonal line is there. Then yes, we can say there is a 9 in the image. So filters are nothing but the feature detectors or feature extractors. Okay, so that is what the advantage is. But why we are starting convolution, CNN convolution neural network, computationally, it is less complex, is what we say. How we are reducing computations, but because of this convolution, the computations are not reduced yet. So how to reduce that? Now let us try to see. So here you have 9, digit 9. So we have loopy pattern filter, vertical line filter and diagonal line filter. When three are there, when these three features are there, yes, we can say it is 9. Right. So then we will be performing convolution. So the first layer is what? Convolution and ReLU. And the next layer is max pooling. And computations are not reduced, but computations can be reduced by using max pooling. How that is done, now let us try to see. So one CNN architecture is given like this. I'll come back to this slide after completion of my lecture. So whether you can understand this or not, you can check it out afterwards. So this is one more application, biomedical applications. Okay, so when you have convolution, and then this is a layer, I'll come to this point detail again. I'll try to show you. So when we try to detect koala, so eye detector, eye features are there. Yeah. So in the image, there are 2 eyes. Okay. And now this picture and this picture, both are not same eyes. They are different. So eyes here, they're located here, but eyes, they are located here. So yes, this, convolution operation will exactly, identifies the eyes. So you have eyes feature, you have, eye detector. When you try to see here, there are 5 eyes. So when you perform convolution, it is detecting 5 because this koala, is looking this side. Then you have hands filter, and then you have nose filter. When these 3 are there, then you try to compare this with one more convolution by it is a head of koala or not. This is how we do human recognition. Same thing like we try to perform in convolution neural network. So then filter it, yes, head is there. And similarly, you have body, hands and legs filter, we try to do convolution. Yes, if both the hands and legs are there, body of koala is there. And then yes, body of koala is there. Then this we try to give it to fully connected layer, that is simple neural network. Okay, so this is feature extraction. The first part is feature extraction. The next part is what? Classification. In digital recognition is also same. You have loopy pattern. You have loopy pattern. So in convolution neural network, we will be using activation function called ReLU, rectilinear function. So what do you mean by this? Now minus 0.1. So anything it is greater than 0, you will be getting the same value because it is linear. And if it is less than 0, it is made as 0. It is less than 0, it is 0. So minus 0.11, it is less than 0. And 1, anyhow, it is there. So it is 0. Minus 0.55, it is less than 0. 0.11, so same 0.11 is what you are getting. So when you try to perform ReLU operation, then this is what you are going to get. So in the top, it is 1 is there, means yes, there is a loopy pattern. So ReLU helps with making the model non-linear. Neural networks, I said, right? Activation functions are responsible for making non-linear. But computations are not reduced yet. So we will try to do this using pooling layer. So before that, let me try to show you one application. Can you see this image? Yes or no? Good. Please interact.
Yes.
How many colors are there?
Pardon, please, sir. Pardon, please.
How many colors are there in the image?
One.
On the top, it is written, right?
I for 7. I
96,615, right?
I for 7 color, I think.
Okay, this is what input image. What you can see in the image, there is a resort.
No,
What
this
you
is
want
not
to see?
your sea. Just water and temple. Tree also
There
there.
is a there is a water. There are trees. What else you can see, sir? There are few boards. There is a harbor, correct?
Yes, sir.
So the size of this on the disk. What is the size you can see? (158 KB). Okay.
Yes, sir.
Now the same image is represented by using 64 colors.
16 colors.
Yeah, 96,000 colors are reduced to 64 colors. Still, we can see all the things available in the image. Yes, there are boats, water. There is a temple and our resort. We can say there is a resort and trees and the few buildings in the back. Okay, that's what we can see. But the size, coming to the size of this. What is the size?
Sir, it is not visible here, sir. I think there is a written, but it is not visible in my side. So large.
109 KB.
Okay, sir.
You can see the screen, no, sir?
It's not visible, sir. I am just taking class on your mobile, sir. Actually.
This is 64 colors. And similarly, this is an image using 8 colors. So background gone. We can see, yes, there is a resort, few trees, some water is there, but background gone. So when it is 8 colors, the size of this image is 38.5 KB. Earlier it was 158 KB, but now, and this is using 2 colors. The entire background gone. But I can see, yes, there is a resort, Chinese resort available. The size of this 10.8 KB. So earlier the image was 158 KB, but now the image is represented using 2 colors, but still we can see what is there in the image. Background anyhow gone. So sometimes background is not important, means yes, 158 KB is reduced to 10.8 KB. So the conclusion is all pixel values are not necessary to represent information in the given image, accepted or not. I repeat, all the pixel values or all colors are not necessary to represent information in an image. 64 colors were also fine. 96,000 colors are reduced into 64 colors. So all pixel values are not needed to represent an information. So sometimes we can neglect these things. How we can do now? Let us try to see. So that is what we try to do using pooling. So the next layer is pooling layer. In pooling layer, we will be using a concept called max pooling. So what do you mean by this max pooling? And now if you try to take, this is what the pixel size. What is the maximum value of the pixel? There are 4 pixels. What are the maximum value of the pixel? 8. So I neglect this 5 and 1 and 2. And then I try to see here 3, 4, 9 and 2. The maximum value is 9. And 1, 3, 2 and 2. So the maximum value is 3. Here the maximum value is 2. So 4 cross 4 image got reduced to 2 cross 2. Is that accepted? So max pooling layer, and here striding means this is what we did first, and we would have done like this. So we would have done next like this. So that is called striding 1. But earlier what we did is called striding 2. So here this image size is of 5 cross 3. But when we try to perform max pooling, the maximum value is 1. Then we will be performing here, the maximum value will be 1. And then we'll be performing here, maximum value is 0.33. And we'll be performing, pooling here, the maximum value is 0.33. And here also the maximum value is 0.33. And here the maximum value is also 0.33. And here the value is 0. And here the value is 0. So 5 cross 3 became now 4 cross 2. The pooling layer is responsible for reducing the computations. Accepted? So this is with striding 1. So this is what max pooling. And now this is with striding. The first layer is convolution layer. And then the next layer is what? Pooling layer. Convolution layer is responsible for extracting feature. And max pooling layer or subsampling layer is responsible for reducing the computations. So how we used max pooling? Similarly, we can do average pooling also. This is with average pooling slide. There is a concept called padding. So what do you mean by padding? When you try to perform convolution, okay, when you try to perform convolution, what is happening is you try to perform convolution first here. You try to perform the convolution, this one. Then the next one is the convolution here. The next one is the convolution here. Right. The next one is convolution. You will be performing convolution here. And the next one you will be performing your convolution here. Now what is happening? The edge pixels are covered only once, is it not? So if information is lying in edge pixels, that will be loose. Right. So then what we'll be doing is we'll be performing a concept called padding. So what we do in padding, we add zeros. Now let us take, you can add zeros here. So when you perform convolution, what you do here? First you perform here, then here. So the edge pixels are covered more than once. That is called padding. Is that padding understood, all of you? So you will be performing first convolution here, the next convolution here, the next convolution here. So edge pixels are covered more than once. So the information will be getting retained using.
Excuse me, sir. Hello, sir. Whenever you find the average for cell, then I think some information will lose here. What's about that?
Average, when you try to do maximum information, you will be getting now, sir.
But sir, some information lose.
How? You will be taking care of all, no? Average of that is what you are reading, no?
Yes, sir. Okay. Yes, sir.
So this is called padding. Coming to the generalization. If you have input image is n cross n, padding if it is p, filter size is f cross f, then output size is n plus 2p minus f plus 1. I repeat, n plus 2p minus f plus 1 is what the output size. And here we call a concept called striding. I told you already, striding 2 and striding 1, shifting by 1 or shifting by 2. In that case, if it is striding, then the generalization rule is n plus 2p minus f by s plus 1. Remember, n plus 2p minus f by s plus 1 is what the formula. So now we'll try to take an image and we try to do. Yeah, this is what a problem, sir. How many pixels are there in the image? 39 cross 3. So the filter size is 3, striding 1, padding not used. 10 filters are used. So what do you mean by 10 filters? Eye filter, ear filter, nose filter. So like that, whether it is there or not. So like that, 10 filters are there. Okay, right? So now, what is n here? N is 39. What is filter size? Filter size is 3. Padding, no padding. Striding 1. So if I perform convolution, what would be the output size of the convolution layer? What is the formula? N plus 2p minus f by s plus 1. N plus 2p minus f by s plus 1. So n is 39 here. Padding is 0. Filter is 3 by 1 plus 1. So what is the size? 39 minus 3, 36. So 37. So 37 cross 37 cross, how many filters are there? 10 filters are there. So is this understood now, all of you, the output of the convolution layer? Now let us try to take it is a convolution. Is that point is understood? Yeah. Now let us try to take, then this is what the input image. Now let us take, this is what it is given to pooling. Now let us try to take the next layer is pooling layer. Then what is the output of this pooling layer? Anyone? Here n is 37. So 37. So padding is used? No, padding is not used. Right. So filter size is 5. So minus 5 by striding. So striding size is how much? 2. Striding is 2 plus 1. So it is 37 minus 5. 32 by 2, 16. 16 plus 1, 17. So it is 17 cross 17 cross 20. So output of this pooling layer. Is this understood, all of you? Now, if you have 39 cross 39 cross 39, if you have 39 cross 39 cross 3, 4563 what the input neurons is what you require. But if you perform the convolution, then the computation is what reduced is what we have to see. So now the next layer is pooling done. And next it is given to, let us take one more convolution layer. What is the output of this convolution? So what is the n here? N is 17. 17 is what input. What is the padding used? Padding is 0. So 0 minus F. Filter size is 5. By striding is how much? 2 plus 1. So 17 minus 5, 12. 12 by 2, 6. 6 plus 1, 7. So it is the output of this layer is 7 cross 7 cross 40 filters. So when it is 7 cross 7 cross 40, 7 cross 7 cross 40, it is 1960. So the neurons now is 1960. So reduce from 456 through 1960. When I try to do one convolution, one pooling, one convolution, one pooling, computations are reduced or not? Is the concept is understood, all of you? Is the concept is understood? Yes, please. This is input data. So convolution 1, convolution 2, convolution 3, convolution 4, convolution 5, then that. So here you have convolution layer plus pooling layer and fully connected layer. The first one is feature extraction, fully connected layer for classification. Okay. Now, in the output layer, you will be using a activation function called softmax. So the softmax, the mathematical equation is e power zi by summation j is equal to 1 to k e power zj. Example, if I have a vector like this, and if I give to the softmax layer, then e power 1.2 by e power 1.2 plus e power 0.9 plus e power 0.4, which is 0.456. And next one is e power 0.4 by e power 0.9 by e power 1.2 plus 0.9 plus 0.4, which is 0.3386. So this is what the softmax layer is, what it is used. Our activation function is what it is used in fully connected layer, not sigmoid one. Okay. Now you tell me, if I show you this is what the convolution neural network of breast cancer detection, then whether you can understood this or not. The input image is 220 cross 227. Can any one of you tell me how you got this from this? If you correctly attended my lecture, and then if you understood this, have you got this? What is n here? N is 227. What is F here? $11. Filter size is 11 cross 11. Padding not used, 0. Striding 4. So striding is what? It is 4. So it is 227 plus 0 minus 11 by 4 plus 1. So how much it is? 55. So the output image is 55 cross 55. And how many filters are used? 96 filters are used. So the image size is 55 cross 96. Original is 227 cross 227. Cross 3 color image. Is this understood? Yeah. So you have a brain image. The first thing is convolution layer, 128 convolution filters with 3x3 size. So then 2x2 pooling grid with pooling layer, 256 convolution filters with 3x3 pooling layer and fully connected layer. So you have normal image or abnormal image, whether you have any brain disease or not. So a brain tumor classification is what can be done by using CNN, convolution neural network. So you have input size, shape. So first layer is convolution, then max pooling, convolution plus max. It will be fully connected layer. So this is what the advantage. So I started my class like convolution neural networks, we reduce the computation. So this is how it reduced computations. So here it is 220 cross 7, 220 cross 7, 3 means, so 220 cross 227 cross 227 is 6129 cross 3. 18,387, but 18,387 got reduced to 9216 and 4096, fully connected layer 4096. This is what the advantage of convolution neural networks, which reduces the computations. Any questions, please? If you have any questions, you can ask me now. So the advantage of convolution is it is invariant, means if the image is location invariant, also we can try to recognize the digit very clearly. So this digit recognition can be done by using convolution neural network, and the advantage is it can reduce the number of computations. If you have any questions, you please ask me now. I'll take up your questions. Madam, that's all from my side.
Sir, thank you.
So Sagar sir is there. If you have any questions, I'll take up, or otherwise, this is what the conclusion compared to the artificial neural networks, convolution neural networks are used, and it is very efficient, as we have seen, reduces the number of computations, and all these things will be running in cloud. Okay, and coming to the Google Cloud, we have Google Cloud.
Hello, sir. Hello. Sir, your voice is not coming, sir.
Now, sir,
Hello.
now. Hello, sir, now.
Hello.
Sir, am I audible now? Hello.
You are audible, sir, but there is a problem on their side, sir.
Yeah. Okay, so if you have any questions, I will try to take up now, or otherwise we'll be leaving. Any questions, please? Yeah, if you have any questions, I'll take up, or otherwise, okay, thank you for listening to me. Thank you.
Okay. If you have any questions, means you can post it in the chat box. Otherwise, we will close the session today. Okay. Any more questions? Okay. Thank you, sir.